Hi, my name is Khoa Nguyen, and this is the tutorial on the AP Calculus BC 2011 question number 6. Okay, so let's take a look at this problem. Let f of x equals sine of x squared plus cosine of x. The graph of y equals the fifth term of the Taylor polynomial of f of x is shown below, right here. Okay, so let's take a look at part A. Now, part A asks us to write the first four non-zero terms of the Taylor series for sine of x about x equals 0, and write the first four non-zero terms of the Taylor series for sine of x squared about x equals 0. Now, some things that you might need to know for this problem is that you need to know the Taylor series and and its concepts in a way. Okay, so let's take a look at the Taylor series formula. Okay, so in this formula, it states that f of a plus f prime of a divided by 1 factorial times x minus a plus f double prime of a divided by 2 factorial times x minus a to the second power, and so on. Okay, so let's take a look at how we got this answer, which is the Taylor series for the sine of x. We first start off with the f of a. Now we know that from the original problem, it states that it's centered around x equals 0. Now that in a sense make a equals 0. Now the sign of 0 would be 0, therefore there is no 0 here. Well, in a sense there is a 0, but then you would not add it to the overall equation. The next term will be the f prime of a divided by 1 factorial times x minus a. Now, translating that, it will be the cosine of 0, which is 1, times x, which is over here, because x minus a would be just x, because a is 0, divided by 1 factorial, which is 1. Therefore, this will equivalent to x. Next we have the f double prime of a divided by 2 factorial times x minus a to the second power. Now before we look at the rest of this, we would realize that the second derivative of sine of x would ultimately be the negative sine of x. Now we know that sine of 0 would be 0, therefore making this whole equation equal to 0. Therefore, we skipped to the next power, which is the third power. As you can see here, it skips from the first power to the third power to the fifth power. Now this follows a pattern of odd, which is 1, 3, 5, and 7. It's also an alternating series in which it starts off with a minus to a plus to a minus. Okay, so let's take a look at the second part of question A. Okay, so the second part to question A is it asks us to write the first four non-zero terms of the Taylor series for sine of x squared about x equals 0. Okay, so let's take a look at the Taylor series of sine of x. As you can see, this is what we got from the previous part of part A. My apologies, this was what we got from the previous parts of part A. Now, taking from that equation right here, we would simply add an x squared to the problem. So as you can see here, the first term, x, will ultimately turn into x squared. And in place of x here, in the previous example, x, it will turn into x squared to the third power. And in this case, x squared, or x to the fifth power, would turn into x squared to the fifth power, and so on. So by the power product property, you would multiply the two powers, the two exponents, and ultimately it will give you this. So the Taylor series for sine of x squared would be x squared minus x to the 6th of divided by 3 factorial plus x to the 10th divided by 5 factorial minus x My apologies. Minus x to the 14th divided by 7 factorial, and so on. Okay, so let's look at the point distribution for part A. So you will get 1 point for the sine of x and 2 points for the sine of x squared. Okay, so moving on to part B. Part B asked us to write the first 4 non-zero terms of the Taylor series for the cosine of x about x equals 0. Use this series and the series for x, sine of x squared found in part A to write the first 4 non-zero terms of the Taylor series for f about x equals 0. Now for this problem, you will need to know the Taylor series and the concepts behind it. Very much like part A, we would use the Taylor series formula to obtain our answer. So let's take a look at the answer for cosine of x. It's 1 minus x squared divided by 2 factorial plus x to the 4th divided by 4 factorial minus x to the 6th divided by 6 factorial. Now let's take a look at cosine of x. Okay, so let's take a look at cosine of 0. So we know that cosine of 0 equals 1. Therefore, making this first term 1. Now the derivative of cosine would be sine, therefore making this whole equation to 0. Therefore, you don't see any first term here. Let's take a look at the second term. So the double prime of cosine will be negative cosine, and then it will multiply by the x minus a to the second power, which would be x squared divided by 2 factorial. This would ultimately equal to x squared divided by 2 factorial, and so on. Very much like part A, this is a alternating series which starts with a negative to positive to negative. However, it differs from part A, in which this is a more even function, or even polynomial, which goes from x squared to x to the 4th to x to the 6th. Okay, so let's take a look at the second part to part B. Okay, so it wants us to use the sine of x squared and the cosine of x to write the first 4 non-zero terms for the Taylor series for f about x equals 0. In equation form, it would look like this. F of x equals sine of x squared plus cosine of x. Now, here is the two equations side by side. Now, we would add both of these equations together to get this final product. Okay, so if you add the two together, you will get this equation as previously stated. You would get the 1 because it's a constant and there's no other constants in the above formula which can be added to it. Therefore, this first variable is 1, or this first term is 1. The second term is x squared divided by 2 because you would take x squared and add it to negative x squared over 2. Now, as you know, adding two fractions together would require a common denominator. Now, what I meant by two fractions is this. So x squared over 1 minus x squared over 2 factorial, which this would ultimately be 2. So it will be x squared minus x squared over 2. Now this would equal to x squared over 2. Right here. So therefore, making the second term x squared divided by 2. Now continuing on with this pattern, you would ultimately end up with this equation. This is the result of the common denominator trying to add up to each other, and therefore this is what we would get. Okay, so let's take a look at the part B point distribution. Now you will get 1 point for cosine of x and 2 points for the f of x. Okay, so let's take a look at part C. Now part C asks us to find the value of the sixth term of the Taylor polynomial at x equals 0. Now for this we need to know the coefficient of a Taylor polynomial and what a sixth term means. Now previously in part B we found out that f of x equals 1 plus x squared divided by 2 plus x to the fourth divided by 4 factorial plus negative 121 x to the 6th divided by 6 factorial, and so on. Now the sixth term of the Taylor polynomial is the coefficient of x to the 6th in the Taylor series for x about x equals 0. Now the question asks us to find the value of the sixth term of the Taylor polynomial at x equals 0. Therefore, the term would be negative 121, which would be your value of the sixth term of the Taylor polynomial. Okay, so let's take a look at the part C point distribution. You will get 1 point for the exact answer. Okay, so let's take a look at part D. Now, part D asks let p subscript of 4 to the x be the fourth degree Taylor polynomial for f about x equals 0. Using information from the graph of y to the fifth term of x shown above in previous slides, show that the p subscript of 1/4 minus f of 1/4 is less than 1 over 3,000. Now, some things that you might need to know for part D is the Lagrange error bound and just error bound in general. Okay, so let's look at what is stated and let's break it down. So what's given to us is the p subscript of 1/4 minus f of 1/4 is less than 1 over 3,000. So we're trying to prove that. So because it gives us 1/4, we know that the range would be from 0 to 1/4. Now what an error bound is it's the actual value of the equation minus the Taylor polynomial approximation. Now the question gives us the fourth degree Taylor polynomial. For the Lagrange error bound, we would need to find the fifth term or the fifth degree Taylor polynomial in order to find the error bound. So let's take a look at the fifth term or the fifth degree of the Taylor polynomial for f of x right here. So substituting in for x minus a, you would have 1/4, and c would be, my apologies, the fifth term of c would be 40. As you can see in the graph here, it's roughly about here as 1/4 of the graph. So right about here would be 40. So moving back to this equation, so then the fifth term of c would be 40, and then 1/4 to the fifth power would be 1 over 1024 divided by the fifth or the 5 factorial, which is 120. Now if you do the math right here, you would get 1 over 3072. Therefore this answer would be less than 1003 or 1 over 3000. Okay, so let's take a look at the part D point distribution. You will get 1 point for the error bound and 1 point for the analysis. Now this has been a tutorial on the AP Calculus BC 2011 question number 6. Thank you for tuning in, guys.